let me introduce you to the Microbit. Microbit is a tiny computer on a little electronics cart. This one has a plastic shield installed over it. You may get one that does not have a plastic shield, still works just as good. The Microbit has several inputs and outputs. I'm going to show them to you very quickly. So first of all, you have inputs. That is your buttons. You got one here and the newer ones have a capacitive touch button up at the top. It has several sensors. It has a thermometer, it has an accelerometer, which tells tilt. For output, I'm going to plug it in so you can see that it has a speaker and it has a little LED screen. The older ones don't have the speaker, but they do have the same LED screen. As I said, you can power it with a battery like this, or it has a little USB port to allow you to connect it to a Chromebook where you can power it and program it. Down at the bottom, you have your pin inputs. These can allow you to attach an alligator clip like so that you can run it to outside tools and sensors. Okay. So when you are ready to connect it to your Chromebook, you take the included USB cord, plug it into the Chromebook and the USB port, and you'll notice that the USB port on this end is a mini USB, so it can only go in one way. So you need to make sure you get it the right direction. And it plugs right in to the Microbit like that. So now that we've got our physical connections hooked up, we're going to show you how to code your moisture sensor. So here in Microsoft MakeCode, I'm going to start a new project. I'm going to call it Moisture Sensor. Click Create. Now, remember we have our stage over here which has our virtual Microbit. Anything that we code will show up on here as it would on the real Microbit. Over here we've got a onStart and a forever loop. I'm going to go ahead and toss the onStart. We don't need it, but we are going to use this forever loop. Now remember, you want to explain to the students that a loop means that it keeps checking it over and over again. So it keeps following whatever instructions are in this block. Then when it gets to the bottom, it goes back up and it starts it again. Now, remember, we've hooked up we've hooked up one lead to the 3 volt. We've hooked the other up to the 0 pin. And what we're trying to test is to see how much electricity is conducting between those 2 paper clips. Here's what we're going to do. Go up here to the search box, and you're going to search for bar graph. And you'll notice that a list of different options pop up. And one of them is plot bar graph of, and it's got a value, up to another value. This is the one we're going to use. So we're going to drop this in the forever loop. So forever, so in other words, it's going to check it again and keep going. Plot a bar graph of something up to something. Okay? So what are we plotting? Well, we want to plot whatever is coming through pin 0. So we're going to go up here and we're going to type analog read, and this should give us analog read pin 0. Now you notice this is oval, so it's going to fit in this oval. So we're going to plot the bar graph of whatever is coming in on analog pin P0. Okay. Up to, so in other words, like how high are we going to plot that bar graph of? The value you want to put there is 1023. So this is measuring how much electrical resistance there is, or I'm sorry, how much conductivity there is. Now, this is going to make a graph here on these red LEDs. So the higher up it gets, the bigger the bar graph. And that's basically going to do it to start with. Now, we don't really have anything here to connect it. You'll see it when we go back to our sensor. But this is the basic bar graph. And at this point, you'll want to send this down to your Microbit by hitting the download key. So let's go look and see what that looks like. So at this point, we're ready to send our program from the Chromebook to the Microbit. The way you do that is you make sure your Microbit is connected USB. Then you go to your download button on the screen, click it. You'll notice that it spins a little bit. That's telling you it's downloading it. And then when it's done, the flashy light will show here because that shows you that you're running a program right now. So let's see if it works. So what I've got here is the bar graph of how much moisture it's sensing right now. Okay, if we take a cup of nice moist mud and we stick this in here, you'll notice that the graph immediately goes all the way up to the top, and it must be a little bit damp in here already because it's already registering fairly highly, but there we go. Alright, we've created our moisture sensor. So our students have created a simple way to measure moisture, and so whenever it gets a signal here on this pen, then it will show a bar graph that shows roughly how much moisture is in that particular ground. But we really want the kids to move forward in their scientific analysis here, so they need to have numbers that they can log and data that they can gather. So we're going to add to our code here. So the first thing we're going to do is we're going to put a variable in. Okay, so we're going to go to variables. We're going to say make a variable. And we're going to call that variable reading, because our variable is whatever the reading is at any given time. So you notice that creates a little oval here that we can drop into places. It also allows us to set the variable to something or to change the variable to something. The first thing we're going to do is we're going to take this set reading, the variable reading, to something. And we're going to put it here at the top of the loop, because remember, it does the loop in order. It does this one first, then this one, then this one, then this one, and so on. So what do we want to set that reading to? Well, that's our analog read pin 0. Okay, so in other words, what's happening here is it's going to take whatever value is coming into pin 0, and it's going to make that the reading variable. Okay. Once we do that, we're going to plot our bar graph again. And now this time, to plot that whatever the reading is, now that we're setting it as reading, we just go into variables and we grab reading. We say, plot us that bar graph of reading. So next, we need to make it so that when we press one of these buttons, it stops displaying the graph and it displays the actual value that it's picking up right then. To do that, we need to do a logic statement. This is sort of the meat and potatoes of programming. So this is an if statement. If something, then do something else. In this case, the if something that we want is if the button gets pressed, and we find that here in inputs. So if button A is pressed, and that goes here, then we want it to show us the value, the reading right now. Okay, the way we do that is we go into basic, and you'll notice it has show number. So we drop show number in here. What number do we want? The number is reading. So what this should do for us is starts the loop, sets the variable reading to whatever's coming in through the analog pin. It shows the bar graph of that variable. And then if we press button A at any given time, it will show us that exact number. And then when it finishes doing that, it goes back up and it starts the loop again, and it keeps doing it, so it's always doing it. So let's see how that works. So right now, let's imagine we've got a variable here. If we press A, that reading is 0. Now that, of course, makes sense because nothing is hooked up. So let's push this down to the microbit and see what happens. So we've got everything hooked up. You'll notice that I've pushed the program down. I have it plugged up into the battery pack instead of the USBs, and I've got my alligator clips attached along with my paper clips. So let's switch this thing on. Okay. Now we'll try the dry dirt first. So let's put these in. You notice that the bar graph didn't go up a lot there, but when I press A, we get a value of 659. Okay, so that's 659. So now let's try it in the wet soil. Okay, got them in there. Now let's press A, and we get a value much higher. Let's see, what was that? It was 1,023. So that's maxed out. So that's our moisture sensor, and that's how we can read our data.